Hello everyone. Today's topic is about limits, and we'll learn how to evaluate the limits and different techniques in evaluating the limits. But first of all, let's start with a background. It's all coming from the first video that I released about secant and tangent. So if you haven't watched it, you go ahead and watch it. And but let me just give you just a small recap on the secant and tangent. We said that if there's a graph of this form and you have a line that is joining 2 points, and we said that that line is a secant line, and we said that this line is joining 2 points on this graph, and point P and point Q. So we said that if you divide f of Q minus f of P, x2 minus x1, this will give you the average slope of this graph. And also we said if you change the distance, let's say the difference of x2 minus x1, let's say this is x2, x1. So we said the difference here, if it represents like h, and we said that h is equal to x2 minus x1. And we say that by making h close to 0, like meaning the distance, we are narrowing the distance. So what happens is that you are bringing this point Q to P. So you have something like, in the end, you have something like this, a line like this, and this line we said is the tangent line. So why is this important? For example, friends, you have a beaker, and then you are filling water inside. You are filling water inside the beaker. The beaker has a volume V, and you are filling water at time t, like at a given time. So you want to know that at time, let's say after 5 seconds, what will be the volume at that time? So what we were saying is, you have a graph of this form. So this is V and this is T. So you have a graph. This is just an example. So what happens is, as the time increases, the volume also increases. So you want to know this, like V2 minus V1, T2 minus T1, meaning T2 meaning the final volume. This gives you the average change in volume, the average rate of change, average rate of change. So, but you're not interested to know at this big interval. You want to narrow down the interval of t. Like you want to know at a particular point. This is called instantaneous. Instantaneous rate of change. So what it means is, let's say you would like to know what will be the volume at time 5, like at 5 seconds or at 10 seconds. So at instant, what will be the volume? So this is why we try to narrow down the difference, the delta t. We try to narrow down to be close to a certain, to be close to 0. So this is an example of limits. The limit actually is it's like you are changing the x value, and you would like to know that if x goes to a certain value, let's say a certain value a, whether it's by moving to the left or to the right of the number line, what will be the f of a? What will be the y value at that x? So this is the limit. So it is presented as limit as x goes to a of f of x. So the answer that you get is L, which is the limit. That means that is the maximum you can get if you are trying to push x value on a number line either to A or either to left or to B or to right. So this is the representation or mathematical notation of what is called the limit. Now, friends, this limit, I think you now know what is the limit. So this limit now, let's now go deeper into this subject. There are some we call them the properties of limit. There's what you need to know about this limit. So what is this? What is this limit now, friends? For example, you have this function is equal to x plus 1. And you want to know what is the limit as x goes to 2. So let's show this using a table. So let's take from the left hand side. So we are trying to solve from different sides. If you see this, it means we are from the left hand side, meaning from the left of that of 0. So, and this it means from beyond 2 coming down, like from 3 coming or from 4 coming down. So let's start with let's start with this. So when x is 1, for example, we want to go to 2. When x is 1, so you find f of x, for example, it will be f of 1 is equal to 1 plus 1, so is equal to 2. So f so is equal to 2. So when x is 1.5, you do the same. When x is 1.9, so you get 2.9. So what about when x is 1.99? You are trying to go closer to 2 but not reaching 2. So let's put one more, 1.999. So basically you can conclude here that as you are moving closer to 2, as you are going closer to 2 here, this is going closer to 3. So, and then that is 3 is the limit when x goes closer to 2. Okay, let's put it here. So from this table we see that the limit here is equal to 3. Now let's see the other one. So as you are moving from up going to 2, that means let's just take from 3. So let's say when x is equal to 3, what would be y? So it's like f of 3 is equal to 3 plus 1. So it's 4. Now what about when x is 2.5? What about 2.1? Let's put 2.1. Friends. And what about 2.01? 2.001. So we can see that this as x goes to 3, as x goes to 2, f of x goes to 3. So we can write this as let's take this thing. So therefore, there is this property, friends. This gives us when limit of a minus f of x is equal to limit x if something like this happens, then limit is equal to a. Like that means the limit exists and is equal to L. So therefore our limit as x goes to 2 of x plus 1 is equal to 3. So that's the answer. So now, friends, let me give you some of the properties of limits, how you evaluate them, of different functions. So property number 1, let me just change color. Property number 1, friends, is if you see this limit as x goes to a of f of x is equal to L. This is what we have in general. But another property is limit of x as x goes to a of c is equal to c, where c is the constant. So, for example, you want to find the limit as x goes to 2 of 3. So 3 is a constant. Your limit will be 3. So that's what it means here. Another property is limit as x goes to a of x c, where c is the constant and x is the variable. The limit will be a c. The limit will be a c. So you just substitute your a into x, and then you will maintain the index or the power. So for example you have x 3. So you want to find the limit as x goes to 2. So this will give you 2, 3. So this is equal to, I think, 8, because 2 times 8, 2 times 2, 4, 4 times 2, 8. So this will give you 8. Now, friends, let's continue with properties. If you have a limit as x goes to a of x, your answer obviously will be a. So you just substitute. And if you have a limit as x goes to a of c x, your answer will be CA. Meaning, if you have a limit, you write it like this. Okay, let me just say this is the same as C limit limit of x. So we find the limit of x, which is a, so this will give you CA. So let me give you another one. If you have a limit of a function multiplied by another function, the limit will be the function multiplied by the limit of that function. And your limit will be times. So we will look at some examples explaining these things, but you have to keep these things because you will need them. They are properties of limits. Now, remaining two properties. Let's find a space. Okay. Yeah. Let's find, okay, another property is limit as x goes to a of f of x. So whereby this f of x is equal to g of x divided by h of x, meaning it's a rational function. So to find the limit of such, limit of this is the same as limit of that rational function. It's the same as limit and this is the same as is the same as here now. The last one is about the infinity. But this, friends, before I forget, this is possible. This is possible. G of A H of A is not equal to 0, or H of A is not equal to 0. So that means if G of A divided by H of A, if you find 0 over 0, then you need to try to simplify it before you substitute. Or if it's, let's say, A over 0, you also need to simplify it before you substitute, because it's undefined at that particular point. It's undefined. There's a rule that I say that there's a rule which says So this rule stands. So never divide by 0 in mathematics. So the function never exists whenever you have a 0 at the denominator. So now let's go to the last one. The last one is about the infinity. Limits at infinity. So what happens is, if you have limit as x goes to infinity, 1 over x squared, then this will give you 0 if n, which is the index, if n is positive, meaning is greater than 0. So if n is greater than 0 and you have 1 over x to the power n, then this will be 0. And if you have a limit as x goes to infinity and you have x to the n, this does not exist if n is positive. You can try it using your calculator. You try x, a big number to the power positive number to the power, let's say 5. It will give you math error. So it doesn't exist. And another point on infinity is the limit of f of x as x goes to infinity, and this f of x is a rational function, meaning it's like this. So on this one, you divide the numerator and denominator by the highest power or index of x. This is how you find it. So I think it's time to look at some of the examples. We'll be applying these properties. So they will make sense when we apply them. Now, friends,